Okay, so let's get started. Welcome to the ECE New Graduate Student Orientation for Fall 2021. And I'm Professor Ying Chen. I'm the Graduate Director. And we also have Miss Christy Lafardi here. She's the Graduate Admin. And both of us will be here to help you during your graduate study at our ECE department. And first, I'd like to ask Professor Narayya Madayam to give us the remarks and then to address the new graduate students.
Okay, thank you, King. So it is a pleasure to be here welcoming our new graduate student cohort. My only regret is I wish we were doing this in person, like we would usually do, and hopefully this is the last time we are doing this in this virtual setting. So again, I want to not only welcome you and congratulate you all for taking the next step, right, which is essentially entering grad school. And typically sort of entering graduate school is a little different from what you might have done as an undergraduate, right, where oftentimes you take a program as an undergraduate and then you go through sometimes phases or courses or portions of your study, right, where perhaps the primary thing that you're studying is not what you're actually focused on at the moment. Whereas in graduate school, you're here in graduate school because you really want to, and you also want to specialize in something. So our department has a variety of options. Professor Chen will talk about the various options available for you. But I want to tell you that we have world-class programs in several topical areas, and we also have a very vibrant group of faculty members that is actually growing younger by the day, right? As we see sort of younger faculty enter our department, and some of our older colleagues retiring. So there's an exciting time to be. And as Professor Chen said, Christy Lafferty, Professor Chen, myself as needed, we're all here to help you and make sure that your stay here. When I say stay, your study here is actually something you enjoy, and not only you look forward to, but also someday when you're done, you can look back upon fondly, right? So we also have some of our faculty colleagues I see here who are going to be making presentations about their research. So I'm sure you're going to enjoy that, and then we will take it from there. My main message to you is we are going through sort of a unique set of circumstances, right, over the last 18 months or so, where we are adapting to things as they happen, and no matter what changes may come our way in the fall semester and spring semester, right, I can assure you that we will be up to the task, and we will make sure that you all have essentially a productive experience, whether it is in your classroom activity, in the courses you take, or whether it is your research. And again, I don't have any other remarks, and unfortunately, I have another meeting I have to go to, so I'm going to leave pretty soon and won't be able to stay here. But if you have any questions, anything, please feel free to reach out by email to any of us, and we'd be happy to respond to you. Okay. So I'm just curious, since I see about almost 55 or 60 students here, how many of you, can you show by hands, how many of you are physically here in New Jersey? I'm curious. And how many of you are elsewhere?
Can you count by hands?
Okay, so it looks like we have, yeah, roughly about half so far. I'm counting, or maybe not.
Yeah, I think about half of the students are here, probably a little bit more than half.
All right, very good. And so that is another reason, right, why, in fact, I would say almost all of our offerings this semester this fall semester are virtual in the graduate program, either in asynchronous remote or synchronous remote. And it is really to sort of be able to accommodate students who are not physically here, and also, due to other constraints at the university itself. But nevertheless, we will make sure that you have essentially the right experience that you need. Okay, so I don't have any other remarks to add other than welcome, and I hope to see all of you on campus, if not later this fall, definitely in spring, right? So I'm looking forward to seeing all of you at some point. Okay, I'm going to hand it over to Professor Chang. Thank you.
Yeah, thank you. Thank you very much, Professor Madayam. Yeah, as the department chair, Professor Madayam actually is a great leadership for us that in the past 2 years under the pandemic, he's leading us going through the difficult time period. And now we're going through the transition, and hopefully we gradually can go back to normal. And then we can see many students on campus and meeting with our faculties, both in class and also in the research labs. And then to have to resume a normal campus study life. Yeah, thank you so much, Professor Madayam. And next, I'm going to have a few faculties to present their research work. And then after that, I will go over the details of the course selection and the guidance for your graduate study here. So next, I'd like to ask Professor Yuqian Zhang to present her research work.
Okay, let me share my screen. That's going to help a little bit. Can you see my screen?
Yes.
Okay, cool. So hello, everyone. Welcome to Rutgers, and congratulations to all of you. So I'm Yuqian Zhang. I'm an assistant professor at Rutgers. And now I'm just trying to give you a brief overview about some ongoing project in my research team. So in summary, my research focuses on the interplay between machine learning, data science, and computer vision. And if you think about what we're trying to do with those tasks, we're always faced with gigantic data, and we're trying to extract some useful and hopefully correct information if we want to make it to be real. And next, I will give you a real example to get started, and I'll talk about something like what's the general discipline I'm trying to do. So this is where we are trying to do some scientific data analysis. This is a collaboration with the physics department. So where they are trying to understand what's the material is going to behave. And you can imagine the material as a neutral silicon material, but it's contaminated by some characteristic atoms or some defects you can imagine. Okay, and when they try to know what's the material it's going to behave, when you have some insight of the material, you need to understand what's the defect in this material. But however, the information you have is basically a gigantic data of microscope images. And those images all always have like millions of pixels. They are taken on a different dimension, different temperature, and different voltage. Okay, and now the information you want to get is what is actually the defects in this material, because they are going to determine the property of this material. And if you try to have a mathematical model for this data or for this task, what you are trying to handle is basically trying to solve this convolution problem, because you can view this material, you view the image of the material, which is why that's a high resolution image, and that can be written as a convolution of some motif, and that tells you the signature of the atom. And also you have the convolution of it against the X0, which says the population of those defects. Okay, so from this model, and you can tell like in this data processing task, and when you are given this high dimensional data, what you actually want to know is you want to extract what's the minimum useful information in this high dimensional data, which is basically this small motif you can show over here, and also how those atoms are populated in this material. Okay, so this is a motivation, like why do we need to care about this process? why do we need to care about extracting information from this material? Yeah, because they're going to help us make better decisions and have better understanding what's the data we have in hand. And if I want to have a more general description of what's going on here, is like, okay, I have this mapping. This mapping is going to take some low-dimensional description of the data. And we're going to have this complicated mapping to a high-dimensional signal. And this high-dimensional signal, which could be an image, with millions of pixels, or could be an article with thousands of words. And once you take this image, you want to extract some information about it. You want to extract what this image contains or what this article describes. And so if we try to cast it as a research task, the problem is this basically, how do we find this unknown description or unknown featured X from this high dimensional data? And also, how can we find this complicated mapping up? Okay, so this process, this is like an abstract generalization of what we want to do here. And doing this could be very complicated because this mapping app is really non-linear and non-convex. And technically speaking, this is very hard problems for us to solve. And another more modern and powerful tool you can think about this is neural network. So the neural network is basically is trying to capture very complicated unknown mapping from this given image to a label. So the label could be, okay, what does an image contain? Is it contains a cat or a dog? And so the task when we try to use the neural network is basically how do we define such a mapping and how do we learn such a mapping? Okay, so this is basically captures the model in a lot of machine learning or data science tasks. And you are trying to extract the useful information from the high dimensional data. And this is basically what my research is trying to do. And we're trying to develop an algorithm and also theoretical guarantee to show that the algorithm works and also is going to capture the information you want to obtain from this high dimensional data. And I think because I only have 5 minutes to go, and this is all the high level idea I can give about my research. I'm very happy to talk more detail on maybe the technical challenges we are going to meet when we try to solve these problems. And I'll be happy to answer your email if you're interested. And we can also maybe meet online, meet in person if the circumstances permit one day. Okay, I will end my presentation for now. So let me know if you have questions or such. So Amy.
Thank you very much, Professor Zhang. And it's a very exciting research areas and across many interesting topics. So students, if you have questions, I think you can also, or interested in Professor Zhang's research, you can definitely contact her. Thank you very much. So next, I'd like to ask Professor Jorge Ortiz to talk about his research. Sure. Professor Ortiz, go ahead and share your slides.
Yep, I will do that. Okay, welcome to orientation here at Rutgers, and I'd like to give everyone the congratulations as well. We're under these sort of strange circumstances, but I think we've been, as a department, managing quite well for engaging with our students. I've had a very lively and productive time in spite of all of it, in large part because of the leadership in the department. So, you know, I really look forward to, of course, transitioning. So I'm the lead PI for a lab called the Cyber Physical Intelligence Lab. If people can mute their mics, that would be great.
Yeah, can the students mute your mics if you're not talking? Thank you.
Thank you. Good. So, you know, in our lab, the work we've been looking at is we want to build sensing systems that learn from engagement with humans. And so we've been looking at various aspects related to sensing, various projects related to sensing in the city, understanding how different sensors are activated based on different human activities. learning preferences of humans automatically using multi-sensor fusion. And we've been applying it across various application domains. One of the unique aspects of our lab is that we span, our work spans from application down to model design from a machine learning perspective. So we design these systems, we deploy them, we collect the sensor data, we design novel deep architectures and models that extract the information we're looking for. And we solve problems in specific application domains as well. So, one example of a paper we recently published, it actually will be presented later this year, is this Project PAS. So in Project PAS, we're looking at this multi-sensed environment in a vehicle. Excuse me a second. A multi-sensed environment in the vehicle. We have sensors, we have multiple cameras inside a car, cameras outside a car. So we're extracting these sort of system factors. We have biosensors that are attached to participants that are driving the car. And we're trying to determine essentially when is a good time to interrupt the driver to give them further instruction, to engage with them for entertainment purposes. And car companies are kind of looking at this space to determine the future car as an entertainment sensor. So here's an example of what the data looks like. I don't know if you can see or hear the video because I'm not sure I optimized it for that. Let me just change that real quick. Okay, so in any case, just to not spend more time on that, since I didn't optimize it for video, that was our data set. Again, we're collecting sensor data, all sorts of sensor data, time series sensor data from the automobile, physiological sensor data, and visual features that we're extracting from the various cameras. And so this is just another view of that, taking physio and CAN data, taking front camera data and data from the drivers. And so here are some of the features that we've been extracting. We do some transfer learning in some of the sub components of this multi-sensor fusion network called PASNet. And essentially our model outperforms the state of the art in this space. And so, we can essentially determine when is a good time to interrupt the driver effectively by fusing all of these various sensing channels together. And we're also able to tune the model so that we can make sure it's safe. So we took the same data and we got some user third-party annotations from folks on Mechanical Turk to determine whether folks would classify it as a safe situation or not. And so we are now setting up this pipeline to be deployed in an actual car where we determine first if it's safe and then determine if it's actually a good moment to interrupt the driver. Now, naturally, what you might ask is, what are the features that are being extracted? I think that's an interesting open question that we're looking at exploring next. We're also looking at these social situations. So can we design these agents that use multi-sensor fusion to determine in a situation where you have more than a single driver in the car, can we determine when is a good time to interrupt the driver, right? To give them instruction. So, and for that, we need to extract these sort of, combine these visual and physiological and car state information in order to determine the general context that's happening in this space. So what this slide here shows us essentially that, yes, the model works and we can determine both safety and good times to interrupt. Another project that we have been working on in the lab is to identify which person is extracting a pill from a pill box. And so from this, we 3D printed a pill box, a pill bottle with a number of accelerometers. And we asked participants to essentially extract a pill and then build algorithms to determine who extracted this. Now, there are many applications around this, just determining whether grandma took her pill or not. In a hospital setting, perhaps differentiating between which nurses did the pill extraction. And there are lots of applications you can imagine built on top of this for medication adherence. And so in this case, we designed a pipeline based on recurrence plots where we have a visual representation of the time series data. And we're able to classify quite effectively who it is that's engaged in this pill extraction activity. The most important thing here is that this is part of a larger suite of techniques that we're looking at for capturing the entire pipeline for medication adherence. Okay, and so it involves a lot of machine learning, and it involves a lot of building of these devices, manufacturing them, putting sensors on them, and running real experiments with real users. Okay, and the last one that I'll give you a little preview on, just to go more into the deeper context, what we'd like to do, one of the things we're doing in the lab is building a continuous learning engine on streaming sensor data. We discovered that, in fact, one of the missing links in streaming sensor data is partitioning the data samples as they stream in, so that we have these discrete samples that we can compare to prior knowledge, right? So for instance, if you observe new behavior, we want the agent to be able to determine that it's new behavior that's being observed, and to know exactly what a sample is so that it knows when to extract features from that particular segment sample. Okay, so in the statistics and machine learning literature, this is known as change point detection. We designed a change point detection scheme that not only outperforms the state of the art using this MMD loss objective function and these sort of dueling autoencoders, but it's also much more efficient to run. And so that's one of the main highlights of this particular work, is that it's more foundational in terms of designing new architectures, but also designing them with performance in mind, because we would like, this is part of a real world continuous learning framework that we're putting together, and it actually has to not only perform well, but be efficient at doing that. And so one of the areas we've been looking at recently is not just occupancy sensing, but just using the continuous learning pipeline to identify different activities as people engage in them in a contactless fashion. We've designed a new sensor as well that we're getting mass produced. We're in the process of doing a large deployment in Weeks Hall for indoor localization, and combining that with ambient sensor readings so that we can determine not just occupancy level, but human activity, the impact on energy consumption, and doing better scheduling within buildings. So that's, you can see that our lab sort of spans a very large area, but the general theme is using sensing in a way that allows you to learn about what humans are doing and how to engage them in the process of making the agents smarter through that interaction. So again, this is just a quick overview. I probably went over the 5 minutes, but happy to talk with students who might be interested in this work, and having folks even sit in on some of our lab meetings if that's something that would interest you. Okay, thank you, everyone.
Thank you, Professor Ortiz. Yeah, this is very exciting, especially for the new sensor that you're going to deploy in the Weeks Hall. Yeah, to see the human occupancy. Yeah, I'm actually also very interested in this, and I also like to talk to you more about this. This will be very interesting to monitor the people's occupancy and also activities inside of the building. If we can get some real data, and using the new sensors, that will be very exciting. We can get many interesting results out of it.
Absolutely. I look forward to chatting more for sure.
Thank you very much.
他叫每一个教授都上来介绍一下他的 research area， 所以就这样。就是他在介绍他现在在做 project， 不一定是论文，对吧？可以听听。
Are you Shenju, are you talking to us, or are you just talking in the background? I think your mic is unmuted. Yeah, I think for students, if you're interested in the Professor Ortiz research, also you could definitely talk to him or take his IoT classes that he's offering. That is, I think it's also very hot topic that people are looking into these days. Okay, so next I'd like to ask Professor Yuan Bo to present his research work and share his experiences.
Can you see my screen?
Professor Yuan, yeah, you can go ahead.
Can you see my screen?
Yes.
Yes.
Okay, hello everyone. So welcome to our ECE department. So I will have a very brief introduction for my review and for my research area. And my main research is on the deep learning and ranging from the efficient algorithm to the energy efficient hardware accelerator design and the security issue of deep learning. And also I'm working on some of the application domains like the applied deep learning to the signal processing and transportation systems. And first, so I think right now in the emerging artificial intelligence area, and so right now, maybe many of you already heard the name of the deep network of deep learning from the social media. And right now, the deep learning technique has been used to be in many important applications, and it can play the Go game. And recently, big news that Google used the deep learning to help the biology research and in our autonomous driving systems. So the deep learning based computer vision algorithms have been used very well. And also in our smartphones, so the speaker recognition has already been used here. And so deep learning has been used very well. And but there are also some of the current emerging challenges here. And the first one is about the efficiency problem. And so right now the deep network models has scaled very quickly, and they'll be very large. And no matter we want to train to produce such very huge models, or if you want to use this model for some of the predictions or for some regression, so it has become the very energy consuming and become the very time consuming. And for example, so right now, if we want to train a single state-of-art AI models, and its energy consumption can be as large as the ones that of the 5 cars consuming their entire lifetimes. So that is a very serious problem, not just a technical problem, but also an environment and social problem. And so in my lab, so one of our research areas to design the efficient deep learning algorithm, and especially we are studying the advanced model compression technique and to reduce the existing AI models for the different applications, and to reduce their model size and to accelerate their computation without or just with very minor accuracy drop. And some of our recent work that we used the so-called tensor decomposition, very advanced math tools, and we apply that to reduce the model size of the deep network, and we can achieve the very good performance in the different applications, in the image classification task, for the video recognition task, and for the speaker recognition task. So we can significantly reduce the storage size and achieve the good speed up without, or sometimes even with the better accuracy. And this is the first area I'm working on. And the second area is about the hardware part. So this is because, so no matter in the mobile end or in the current data centers, so because the deep neural model is very large and they cause a lot of the energy consumptions, and also become pose very severe challenges on the underlying computing platform. Actually, that calls for some of the new hardware that can be more adaptive for the new working load that brought by the AI technique. And another research directions I'm working on is to design the energy efficient real-time AI hardware accelerator. And in the last 4 years, we have already developed several different type of the deep network hardware architecture, and they ranging from the efficient hardware for supporting those the convolution networks that's mainly used in the computer vision, in the use for the video recognition, and also for some of the hardware more suitable for support the workload like the speaker recognition and the natural language processing. And our design hardware can achieve the very significant improvement in terms of like the speed up, in the throughput, and in the energy efficiency. And so the third research area I'm mainly working on is about the security issue of deep learning. This is because the deep network, one of currently its big drawback is kind of its vulnerability for many attacks. And so especially considering that right now the deep learning technique has been used in many critical systems. And for example, in autonomous driving. So how to properly protect those deep neural models against those attacks, that is very, very important and very, very urgent. So for example, some of the researchers already found that, so if we just slightly modify like the speed limit sign, and then so it can fool the deep neural models that right now used in the autonomous drive, like in the Tesla's autopilot, and then the software will think that the speed limit is the 85 instead of the 35, and then that will cause a very, very serious consequence. And then so right now, how to efficiently protect and also investigate the vulnerability of the deep learning models, that is a very important research topic. And in the recent 4 years, my group has widely studied the deep learning security issues for the different applications, like collaborated with the Professor Ying Chen. So we studied the vulnerability and the robustness of the deep learning technique in the audio systems. And we also studied the vulnerability in the computer vision, and also for the graph neural network, its robustness and the vulnerability. And for example, so we proposed a real-time attack method that we can very significantly reduce the launch time to perform such the attack for neural network, and that can be help us to more efficiently understand the weakness and the vulnerability of the deep learning models. So if you are interested in the AI or the machine learning areas, actually our department has a series of them very related course. So I just list part of them here. So you are encouraged to take those courses, and for example, I think the machine vision course and the machine learning for IoT course, that's from the Professor Zhang and the Professor Jorge. So you just heard their presentations, and I'm teaching the introduction to deep learning course, and we also have several other machine learning and AI courses that are offered in our department in the fall and the spring semester. So you are very welcome to attend that. And one last thing that you are very welcome to attend our weekly Rutgers Efficient AI seminar. So this is a seminar I studied this spring semesters, and we will continue. And we are having that so in this summer, and we will continue that in this fall. So I think Christy will send you the emails for our weekly seminar link. And also, if you missed the previous seminar talk, so you can go to this website and to see that our recorded YouTube videos. And the next seminar also that is end of the last one in this summer semester will be the next Tuesday. So you are welcome to attend this seminar. Okay, so that's all of my presentation.
Thank you very much, Professor Yuan. Professor Yuan is working on this artificial intelligence and also hardware and security area. So this is, we all know that artificial intelligence is helping us in many aspects these days. So it's a very interesting area that I think definitely students will take classes along that direction. So you can see that from our department, there are courses related to machine learning and also deep learning. And so that will be many opportunities for students to explore. And especially like the efficient AI seminar that Professor Yuan is holding these days for every week. This has a focus on the efficient AI direction, and he's inviting many faculties from other universities and also researchers from industry that to present in the artificial intelligence area. So for this part, I would think that will be very helpful to students to gain knowledge. Okay, well, we say that even if you're not doing any research work in that area, but you can broaden your knowledge by going to those seminars. Yeah, okay, yeah, so thank you so much for the professors, for the faculties who gave the presentation today. And we actually also have many other faculties doing interesting work. So you can take their courses and also talk to them, just stop by their lab and chat with them to see if there are any research you like to conduct with them. Okay, so next, okay, I'm going to share my screen and to go over the graduate student handbook and also go over the course selection opportunities for you during your study here. And so let me share my screen. Let's see if I can. Somehow I can, okay, I think I can. Okay. Now it's good. So I hope all of you can see the graduate student handbook that I'm sharing right now. And actually, I also like to share the course selection sample. Just give me 1 second. I like to share them side by side. So that will be more efficient in that way. Just give me 1 second. I can do this. Okay, so I'm share my whole screen to you now. So yeah, so welcome for the starting for the graduate study here at Rutgers ECE department. And you can see that for the first part of the graduate student handbook is to tell you how to do the application, okay, for both the master's program and the PhD program. And you have already passed, for the students here, you have already passed that stage. So now we can start looking at okay, what you're going to learn, okay, as you started your study here at the ECE department. So I'll go through the master's study plan, and then I'll go through the PhD student study plan. And together, okay, I have come up with this file, okay, in this file on the right-hand side, it is a sample, okay, for the master class when you start here. That is for each major or each concentration that what I'm talking about. And I'll also go over for the PhD course selection. I also have a sample so that you can take a look. I usually emphasize on the first year's study. And once you get familiar here, for the second year, you're free to discuss with your fellow students. And I think you'll get more familiar with the environment here so that you can decide on what courses you're going to choose in the second year and for the PhD students for the following years. Okay, so for the master student, you're going to complete 30 credits during your study here. So for this 30 credits, if you're a transfer student, if you have already studied some graduate courses in another university, or you have already got a master's degree and you like to transfer credits over, you can transfer up to 12 credits into the master's program. And then, okay, you need to study the rest of the credits here in the ECE department. And also, I like to talk about, we have the thesis option and non-thesis option. So we're going to go over that, okay, when we after we talk about the course selection. So there are two routes for you. One is the thesis option, master thesis option. The other is the non-thesis option. Okay, so first let's look at I'll go through the 6 majors quickly. Okay, so we have 6 we can call 6 majors or 6 concentrations in the master's program. And we recommend you to choose one major and then so that you can follow your course selection along that major. But this is just a guideline. For the students, okay, you can also be flexible to choose the courses from other major or other concentrations. So in the communications engineering, okay, what we have is that you have required courses, okay? You have required courses, okay? And also you have elective courses. Okay? So what we usually look at, okay, what we look at is that, for example, for the communications engineering, okay, on the right-hand side, I show you the course samples. So we like to ask you to take 4 courses, okay? And then the 2 courses from the recommended elective courses and 2 additional courses, that is elective courses that you can take from other departments, okay? So this for the students with the thesis option. For the thesis option that you're going to do a master thesis, that means that for the second year of your master study, you're going to try to find an advisor that you can work with to do some research work in his or her lab. So during that time period, for the thesis student, the master thesis will last for 2 semesters for 1 year, and it will count for 6 credits, 3 credits for each semester. And at the end of the second semester or towards the end of the second semester, second year, that you're going to write a thesis, and your master thesis advisor will guide you to write the thesis. Okay, so that is why, okay, for the 30 credits, that indicates 10 courses, right? So here, if you're a master's student with thesis, so you're going to take 4 core courses, 2 courses from the recommended elective courses, and then 2 additional courses at your flexibility. So these are 8 courses. And the rest of the 2 courses will be your master thesis course. And for students who take the non-thesis option, you're going to take 5 core courses, okay, every elective courses, and then the 2 additional courses of your choice. So you can see that as a non-thesis student, basically your master's degree will be taking courses. You're not going to involve in any research work. You're not going to involve in any research work. Okay, So for the non-thesis student, at the end, we say that towards the end of the second year, we ask you to write a technical paper. And this technical paper, usually it was a semester long of work. So if your 2-year master thesis study, during your 2-year master thesis study, for the second year, the second semester of your second year, at the beginning of the semester, okay, we ask you to talk to one of the professors to work on a technical paper. So the technical paper is usually related. The technical paper is usually related to your course. So you can convert one of your course project into a technical paper by talking to the course instructor. So you're going to expand your course project with the guidance of your course instructor and write that the course project as a technical paper. Or if some student, you're doing some research work with the professor, but it's not at the level to the thesis, you can also write it as a technical paper. Usually the technical paper, the effort of the technical paper will last for 1 semester. So we strongly encourage you, for the students who take the non-thesis option, you need to start preparing your technical paper in the second semester, at the beginning of the second semester of your second year of the graduate study here. Okay, so as that said, okay, I provide you the samples, for example, for communications engineering. If you take the major as the communications engineering, this are the sample courses, okay, that we show here. What are the offering for the core courses and the recommended elective courses for your first year, okay, what are being offered in the fall 2021 and what will be offered for the spring 2022, so that you have a good planning for the first year of your master study. Yeah, as Professor Madayan pointed out, that for the graduate study, it is different from the undergrad study. For the undergrad study, you have the course Navigator to help you, basically to guide you go through almost each semester's each semester's courses that you can choose from, especially for the freshman and the sophomore year. But for the graduate study, basically you need to decide. You need to decide what you're going to choose. You have more flexibility, but also more responsibility for yourself. Okay, this is what you're going to graduate school for. You're going to become more independent and more responsible to do what you're going to do. So we start, okay, with the course selection here. Okay. And then, okay, for the second major, computer engineering, okay, also, okay, for each, okay, I'm not going to repeat it again, but for each major, okay, we have the thesis option and non-thesis option. So we have it listed very clearly, okay, in the graduate student handbook. You can take a look of the details here. Okay. So for the computer engineering, okay, currently many students are choosing computer engineering as their concentration for graduates for the master study. So we put, you can see that in addition, okay, to the core courses, okay, in addition to the core courses, we show what are the possible elective courses, okay, and also the courses from other departments. Okay, and at the right hand side, at the right hand side, okay, I show you what are the plan, okay, you can do. What are the plan that you can do for your first year of study here? Then we have this digital signal processing. Okay, so digital signal processing, we also listed the requirements here, okay, and also the sample courses. And then we have the software engineering. This is also the sample for the software engineering here. And the solid state electronics. And the last one, the systems and the controls. Okay, so these are the samples that you have for the 6 majors. And I would also like to actually point it out. I want to go to the certificate programs quickly. Okay, so for the left-hand side, if we go back to the graduate student handbook, you can see that for these 6 majors, okay, currently we do not have this cybersecurity and machine learning. Okay, we are in the process of create cybersecurity and machine learning as our concentration as well. And meanwhile, starting from 2021, we offered the certificate program. The certificate program, okay, for the graduate student in the ECE department is that in addition, okay, to a master's degree, if you fulfill for your courses, if you choose your courses carefully, you fulfill the need of the certificate program, you can also get a cybersecurity certificate or a machine learning certificate at the same time. Okay, well, the certificate program is also open for the grad students from other departments, or even for the students, the non-degree students, that they are the professionals already working. So the certificate program is to let the students learn and have some concentration in one area, that they'll be trained, okay, for the machine learning area or for the cybersecurity area. That is mainly for the benefit is that later on when you go out on the job market, it will make the students become more competitive. Okay, so we also offer this certificate program. So during your master study, since you're already in the ECE department, during your master study or during your PhD study,
okay.
If you plan your courses carefully, you'll be able could the students mute your mic? I see you cannot mute the mic for you. Thank you. Okay, and I'm also going to check the questions from the chat from time to time so that I can answer them. Okay. Okay, one question is that, let me see the question. Okay, for the computer science course, machine learning and database courses, they're not interchangeable, but you can take them as your elective courses. And also students also ask, are those sample courses mandatory for thesis option? Those are just sample courses. They are not mandatory, okay? The sample courses basically to tell you what are being offered in the fall semester and what will be offered in the spring semester. So those are not mandatory, but those are just a guidance for you to take. Okay, the certificate programs. Okay, are the students' questions that are the certificate programs 0 credits? You can see that. Okay, if you're already an ECE student, the courses in the certificate programs are overlapping with your core courses or elective courses. So if you're taking courses and elective courses, that are certificate courses, you can apply for a certificate when you apply for a degree. But for the students from outside of the department, or students that they're the non-degree students outside of the university, when they are taking the certificate courses, the courses inside of the certificate program, they're going to earn credits. Okay, yeah, student is asking that is if they're admitted into the BSMS program, how do they navigate course selection, having taken some graduate courses in their undergrad? Yeah, actually, I'm going to touch base talking about the 4+1, the 5-year program. And since you're asking right now, so let me just jump into that part. We have quite a few master students. They're being admitted into the 5-year program. That said is that they have already taken, some of the students, they have already taken graduate level courses during their undergrad study. So in that sense, all the graduate courses they took during undergrad study can be or will be counted in your master's study. And the 400, if you have any 400 level courses that you took during undergrad study, but they have not been counted towards your undergraduate bachelor's degree, those 400 level courses can also be applied into a master's degree. The limitation is that those 400 courses cannot be, the transferred 400 courses cannot be over 12 credits. Okay, so in that sense, if you have already taken grad courses during your undergrad study, all of those courses could be applied into your master's degree. And then based on what you have already taken, you can look into the what will be offered in the fall semester and the spring semester and decide what are the rest of the courses. And I also would like to say that, sometimes students, they also get worried, like by the 5th year, they feel that they cannot finish the 5-year program. They're asking whether they can have 1 more year or 1 more semester to get their master's degree done. And the answer is yes. If in the case that you cannot complete your master's degree, okay, after 5 years, you can always have 1 more semester or 1 more year to get your master's degree done. Okay, so students are asking how many credits we can transfer from master to PhD. Yeah, I'm also going to touch base on that in a little bit. For the PhD program that I'm also going to talk about, but now I'm just going to address it. For master to PhD program, there are 24 credits you can transfer. Yeah, if you want to open your mic to ask a question, that's also fine. Okay. Yeah, great. Christy has already answered the question. Okay. Yeah, go ahead.
Can you hear me?
Yes.
Hi. Yeah, my name is Justin, and so my area of focus is software engineering. So I'm looking at the student handbook right now. So for non-thesis option, we have to take 3 core classes, 5 courses from the software engineering group of elective courses. So my question is, for those 5 courses of electives, can all those 5 courses have to come from the like the software ECE software engineering elective courses, or can we take equivalent of CS elective CS courses?
Yeah, the answer to that question is yes. Yeah, for the 5 elective courses, not all of them needs to be taken from ECE department. You can take from outside department. Yeah, and I think usually the limit is that you need to have we like you to take at least 21 credits. We're working on some curriculum revision with the faculty working group. So the limitation is that we need you to take like at least 21 credits from the ECE department. And then for the 9 credits, like up to 3 courses you can take from outside of the department.
Okay. So so that means 5 classes. So that means we have to take, so 2 classes, so we can take 2 classes from the EC department and 3 classes from CS department.
Yeah, if you, yeah. And then for the 2 additional courses of your choices, then that will be in the ECE department in your case, yeah. But usually, okay, what we do is that for the 2 additional courses of your choices, for this part, you can take outside department courses.
Okay.
Yeah,
Okay.
because the thing is that you're getting overall, you're getting a degree from electrical and computer engineering, right? So that is why we would like you to have the majority of the courses you took need to come from the electrical and computer engineering department.
Okay, sure. Thank you so much.
You're welcome.
Professor?
Yes.
This is Aditi here, and I actually took up programming finance this semester, and I'm on the software engineering track. It's not listed anywhere on the handbook, so I wasn't sure whether it falls under the ECE group of electives or not. But it's in the
That's fall into the elective courses. Yeah, that course fall into the elective courses.
Within the software engineering
Yes,
track?
that's fine. Yeah, that's fine.
Thank you.
Yeah. Okay, so I'm going to move on. Okay.
Oh, hi, Professor.
Yes.
I'm sorry to disturb you. Varun Desai here. Can you go through the next question from the chat room? It's for the solid state electronic.
Yes.
Yeah, it says that as per the PDF, yes, we can see that for the non-thesis option from the PDF. Yes, the 3 core courses, 5 courses from the software engineering group of elective courses, right? So do we need to select that 5 courses from the software engineering group of electives, or we can select the recommended elective courses from the solid state electronic itself?
Yes, of course you can. Yes, you can. I definitely think that you can choose courses from the solid state and also the other part. I think this part actually should be a typo. We shouldn't ask you to take all from the software engineering group of elective. You should have the flexibility. You should have the flexibility to take the electives from the other majors.
Okay, so we can select
so for
from
this
software
part, I'm
engineering as
going
well
to
as solid
update
state
it.
as
Yeah,
well.
I will update this part.
Okay, thank you.
Okay, so let me go on. So this is the part that we talk about the course selection. So I hope this provides you a good guideline about that. And I also talked about master thesis and also the technical paper. And we put down clearly, okay, what are the candidacy forms that when you're ready to graduate, and be mindful of the dates that you need to get prepared. Okay, if you're a master thesis student, you need to defend your master thesis ahead of time. And if you're a technical paper, non-thesis student, you need to get a technical paper ready and read by 2 faculties in addition, okay, to your technical paper advisor. Okay, and then you need to be mindful of the dates that before that you need to submit your candidacy form to apply for the diploma. So those are the important information that you need to keep in mind. And you can always check with me and also check with Christy Lafardi on this part. Okay, and we also list the checklist here for you. Okay, so given that, okay, I'll quickly go talk about the PhD degree requirement. Okay, and before that, okay, actually I want to mention is that for the master students, okay, okay, we have the regular master students. They're going to study 2 years of master's study. If they can finish their work quickly, some of them want to graduate in 1.5 years, that is also fine. And also we have this 5-year BS-MS program that the student here at Rutgers, when they're done with their BS degree, some of them, they can complete their master in 1 year time period. So we call this as 5-year BS and MS program. But if some student, once they get into this program, if they need more time to complete their degree, we usually grant them, okay? And we also have 3+2 program, okay? That is joint program, okay, with 2 universities in China. And for this year, seems like we do not have 3+2 students, but for previously, we always have quite a few 3+2 students. That means they study their bachelor's degree 3 years in their home university and then come to Rutgers ECE to do the last year of bachelor's degree and then +1 year of master's degree, and 3+2. After the 4 years, they get a bachelor's degree from their home university and their master's degree from Rutgers ECE department. And they also have some specific course requirements that they need to fulfill. And if we have any 3+2 students, please do let me know, okay, for this academic year, that I can go over the details of the course requirement with you guys. Okay. Yes, the question you don't have yet for the students specialized in solid state electronics. You do not have to take all of the electives from software engineering. Yes, you're right. Yeah, for the question, the student have that as international student, they're concerned about legal status as it's mandatory to have on-campus classes and only 1 online class. We actually have already loosened the bar on this and updated the graduate student handbook. So currently during the pandemic time period, if you read that part of the paragraph, we talked about you're not required to be on campus to take courses. Okay, you're allowed to take courses through online. Okay, previously, because we always have on-campus courses, so we like you to come to take courses. But now it is fine that you can take online courses. Yeah, we have this updated in the graduate student handbook very recently. Yeah, thank you, Professor Ortiz. Okay, so let me move on, and I like to actually share I also have let me see, for the PhD student course selection sample. I would like to put it side by side so that you can take a look together with this. Okay, so for PhD students, okay, the PhD degree requires a total at least 72 credits. Okay, and among them, 36 credits are for the coursework. Okay, and then 24 credits. Okay, 24 credits are for the research. Okay, that you're going to register with your PhD advisor. And among this, okay, additional 12 credits that can come from either coursework, okay, or your research credits. Okay, given that, one thing I like to talk about is that for the master student, okay, for the master students, okay, I talked about for your thesis degree, right? When you do the thesis option, you have the 6 credits that you're going to register, okay, for your second year to do your master thesis. And for the non-thesis student, when you write a technical paper, you can actually register 3 credits as an independent study with your course instructor or with your advisor. And for the master study, I also want to point out, you can also even if not for your technical paper, you can also register for independent study if you like to do some research work, but not to the level of the thesis work, right? You can still register a course for independent study with a professor if you want to work on some of the research problems. Okay, so what you have is that we have coursework credits, independent study, okay, it will also be counted as coursework. And they have the research credits. That is usually for students who are working on the master thesis or for students who are working on towards their PhD degrees. Okay, and then we also offer this colloquium. Okay, I also like to mention is that for the master students, they need to take 2 semesters of 699 colloquium in electrical and computer engineering. So this is important. The 699 colloquium, it's a requirement for both master and PhD student. We require master students to complete 2 semesters of colloquium course and PhD students to take 4 semesters of colloquium. So what are the colloquium? Colloquiums basically are the talks or presentations that when we invite speakers from other universities or industry, okay, they come and show their research work. And the colloquium usually lasts for 1 hour. And previously we have it being held from 10 to 11 on Wednesday morning. And for last year and this semester, this coming semester, the colloquium are being held online. And for the coming semester, for the fall 2021, we like the students, we have the live colloquium, and we need the student to log in, okay, to attend the colloquium, okay, on Wednesday morning. If we have a speaker coming in, Christy will send out the invitation to all the grad students. And if you're registered for the course, you need to attend the colloquium. And the colloquium will be graded as satisfactory or non-satisfactory. If you attend 80%, okay, of the talks, okay, you're going to get a satisfactory grade. And this is a requirement for the graduation for master's degree 2 semesters and PhD degree 4 semesters. Okay. And a very important thing about the PhD program is that when you study as a PhD student, you need to study and pass the PhD qualifying exam. The PhD qualifying exam, it is best for you to get it done within the first 2 years after you join your PhD program. If for some reasons you cannot get it done after 2 years, that you can ask for extension, and usually it will be granted. Okay, so for the PhD program, for the qualifying examination, okay, there are 2 parts. There are 2 parts for the qualifying exam. Okay, the first part, okay, is the course requirement. The course requirement is that is the part that you need to work on for the first 2 years. Okay, for the course requirement, as we talked about, for a PhD study, you need to complete 36 credits for the coursework. If you have already got a master's degree, you can transfer up to 24 degrees over. Okay, and then, okay, for the rest of the course credits, you need to work towards the qualifying exam. So you need to take 4 courses within the ECE department, 4 core courses, okay, related to the concentration that you're going to choose, or from the guidance of your advisor. So you're going to take 4 core courses. Okay, and this 4 courses, you need to maintain a GPA of at least 3.75. And then for the breadth side, you need to take a math course. You need to take a math course to fulfill the course requirement. You can, of course, you can always take more than 1 courses if you like, okay, from the other departments. But we require you, okay, to take at least 1 math course from mathematics or physics or statistics department. And you need to have a grade of B+ and above. Okay, so this is very important. Okay. So some students are asking whether you can transfer, for the transferred credits, can they be applied to core courses? No, you cannot. Okay, the core courses, the 4 core courses, and also the math courses, the math course, the 1 math course, you need, those need to be taken, okay, at Rutgers University, and the 4 core courses need to be taken in the ECE department. Okay, yeah, thanks, Christy, for answering questions for me. And I see the students saying that if you're taking the online courses this semester, you can choose take online courses at home instead of going to US. And if you already got your visa, I'm not sure whether you need to reapply for your visa. I think you need to talk to our global Rutgers Global Services about that. But if you can come online, if you come on campus, if you already got your visa, I would encourage you to come back on campus, because for this semester, although most of our courses are offered in the hybrid mode, it's a good time for you to come back to campus and then get familiar with the campus and settle down in the environment here. So the student is asking, have the same courses in the master study, which is core courses now. Is it possible to transfer it? If it's to the PhD study, you cannot. If it's to the master study, that is fine. The student asking, if the core course does not open this semester, can I choose some similar course from other departments to meet the core course requirement? The answer is no. As I said, the 4 core courses need to be taken in the ECE department. If the core course you want to take does not offer this semester, you can wait for the next semester to take this core course, or you can choose another course as your core course. But again, this is a strict requirement, okay? There are no other way to get around with it, okay, in order to fulfill the qualifying exam. Okay, so, and once you fulfill the need for the first part of the qualifying exam, then you can submit your qualifying examination application form to me, and we'll try to move to the second part of your qualifying exam. So first, okay, once you are done with your course requirement, you apply for the qualifying exam, then I need to approve it. And after that, we're going to schedule for your second part of the qualifying exam. So for the second part of the qualifying exam is related to your research work. So in the first 2 years, okay, you need to find an advisor that you work with. And many PhD students, I believe that you have already chosen your academic advisor to work on your dissertation. And the second part of the qualifying exam is to evaluate your research ability. So you need to have a paper ready. Either the paper is already being accepted by a conference or by a journal, or the paper is under submission to a conference or to a journal. And based on that, okay, you're going to present your research work to a qualifying committee. And we have simplified the process, is that the qualifying committee will consist of 2 faculties, okay, other than your advisor. So we're going to have 2 faculties. You're going to present your research work in front of them. And the qualifying exam, okay, can be scheduled, okay. One is that during the summertime, okay, for the months of June, July, and August, the qualifying oral exam can be scheduled anytime during the summer. And for the regular semester, now we have the last 2 weeks of October or last 2 weeks of March. We're going to schedule the qualifying exam. So if you plan to apply for your qualifying exam for the fall semester, we'd recommend you to submit your request before the end of September. And if you plan to schedule a qualifying exam in March, in spring, we need you to submit your request by the end of February, so that it gives us to notify the professors who are going to be in your qualifying committee, and also give us the time to schedule the qualifying exam, because professors, they're usually very busy, and it is not easy, okay, to find a time that's agreeable, okay, for your qualifying committee. Okay, so we have 9 areas of the PhD qualifying exam. So this means that when you take core courses, okay, you'd be better to take your 4 courses in one of the concentration, okay, that we have here. If in the case that you're taking courses, okay, 1 or up to 2, and not the courses in one of the areas, but the core courses in the other areas, then you need to ask your advisor to write a petition for you. Usually that should be under the guidance of your academic advisor, that who want you to take a core course, okay, from the other areas. Okay. Okay, I see another question. Can part-time MS students register up to 9 credits for a semester? Yes, yes, you can. Students are asking that, I heard that certain 400 level courses from my undergrad work can count towards my 5-year master's degree. Yes, I think I have already talked about this in the beginning part of the orientation. The 400 level courses, if it's not being counted in your undergraduate degree, not being counted in your bachelor's degree, you can use them in your 5-year master's program. And there are up to 12 credits of 400 level courses that could be counted. Okay, so let me go through the 9 areas quickly. Okay, for each area, I show, okay, what is being offered as core courses, and also the sample possibility for you to take as the math course. Okay, so this again, okay, these are the guidance. Okay, these are the guidance for you. These are the guidance for you, and then you can decide whether you want to take them or not. Okay? But usually I think this is very helpful for the first year. PhD students. Okay. Okay, so these are for the course selection. Okay, course selection part for the PhD student. Okay, and also I like to talk a little bit, okay, about the PhD proposal presentation. Okay, after you're done, after you passed your qualified exam, most likely, okay, you're going to continue to do your research work. And the average PhD study here in the Rutgers ECE department is about 5 years of study. Some students, they're very effective. They publish many papers in the first 4 years. So they can graduate after their 4 years of PhD study. And some students, after 5 years, they still would like to have more time to study and do research and publish. So you can study up to 7 years for the PhD study. Beyond that, your advisor needs to write a justification, needs to write an extension of your PhD program to extend your PhD study. And usually before 1 year of your graduation, the dissertation, you need to do a proposal presentation, PhD proposal. So in the PhD proposal, we will form, okay, a committee. The committee will be 4 members. In this time, your thesis advisor will be the main member, and then 2 other members, okay, from our department, and you're going to have a 4th member as the outside member, either from another department or from another university or company to serve as an outside member in the thesis committee. So in your PhD proposal, you'll form this thesis committee, and most likely this thesis committee will also serve as the committee for your final dissertation presentation. So in the proposal presentation, you will show that what you have done in the past 3 years or in the past 4 years. And the committee member will provide you guidance, okay, to whether they are satisfied with your research work and what you need to do, okay, in the last year before your graduation. Okay. And after you're done, okay, with the PhD proposal, this indicates that you're on the right track to graduate. Then in the last year of your program, you can prepare your dissertation. You can focus to write your dissertation and wrap up your research work with the advisor and or any other lab members that you have. And the final PhD dissertation is the most important one. It will mark, okay, as the success, okay, of your hard work in the past 5 years. Okay, and I think, okay, any student who passed the stage, okay, for the dissertation presentation in front of the dissertation committee, okay, this is a great achievement, okay, of your graduate study. Okay. Okay, so finally, okay, I like to talk about the practical training. The practical training, okay, it's an important aspect that both master student and undergrad student will encounter that you need to keep in mind. So practical training, we have 2 types of practical training, CPT and OPT. CPT is called Curricular Practical Training. For CPT, it is a practical training that is during your study, during your program. So that is a chance for either master student or a graduate student or a PhD student to find an outside work opportunity in a company, okay, to enhance your industry experiences. Okay. Now for the OPT, optional practical training, okay, that is usually after you're done with a master's degree or after you're done with a PhD degree, you're going to use that, okay, to look for jobs. And also when you started your job, you're going to use the OPT for a while before you get, for example, H1 visa for the international students. And the CPT, okay, CPT now we allow, okay, both master students with thesis option or non-thesis option to apply for CPT. And if it's during the summertime, okay, you can apply for the CPT, okay, up to 3 credits. Okay, for 1 to 3 credits during the summertime and also during the regular semester. Some students that they would like to have after the summer, they like to extend to do the internship. So you can also register for 1 credit during the regular semester. And for any on-campus work, outside of ECE department, you do not need to apply for a CPT. So the CPT usually, okay, is for grad students who obtain an internship in a company outside. So we talked about, okay, what are the course number that you can choose, okay, to register for the CPT credits. And also for the PhD students, when you obtain an internship and you register for the CPT, you usually need to get the permission from your advisor, and hopefully your internship experiences will become a part of your PhD dissertation. And once you registered for the credits, okay, it could be either research credits for master's students with thesis option and the PhD students, or for non-thesis student, you can register for special problems, or we say the independent problems credit. Okay, and you need to write a short technical report about the CPT research. Okay, and this will be reviewed by your advisor and also the graduate director. And the CPT courses, the research credits and special problems course will be graded for you. Okay, and for the OPT is that when you're about to graduate, okay, usually before 2 to 3 months of your graduation, if you like to work at US, but you do not hold a US citizen, or you're not a US citizen, or you're not green card holder, you need to apply for OPT. This is for international students. You need to apply for OPT, and when you apply for OPT, you're going to get a working permit. Then this will allow you to find a job in US to get you started. Okay, so so this covers most of the part that I like to talk about today. Yeah, thanks a lot, Christy, for helping me answering questions. So do we have more questions? Yeah, you can also open up your mic to ask questions.
Professor Chen, I heard that we can take classes from Princeton University. Can you elaborate on that?
Yes, yeah. You can take courses from Princeton University, and those courses will be counted as electives in your coursework. And if you're taking courses outside of Rutgers, please do let me know. And usually I will just go ahead and approve it. And also I have another document I'd like to share with you quickly. This document, okay, this document is a list of courses, okay, that is actually for both master student and PhD students, you can choose from, okay. Those are for the applied mathematics, biomedical engineering, okay, MAE, industrial engineering, okay, and also from business school and computer science, statistics. So those are the sample courses, okay, that are related, okay, to the electrical and computer engineering major here. So those are the courses that you can choose, okay, from outside of the ECE department. And I marked some of the courses that they're offered. They're going to be offered in fall 2021. And you can take a look, and you can use this list as a guidance, okay, when you want to choose courses from outside of the ECE department. Okay. Okay, so I think one question is that for students who come to the orientation late, yeah, this orientation is being recorded. So later on, we're going to post it, and you can, you'll be able to find the recording in the web ECE webpage, so you can go over it. It said, will thesis option and non-thesis option affect my future PhD application or career? Well, that is hard to say, right? If you apply for a PhD degree or looking for jobs, a lot of times, especially for PhD application, advisors and universities, they look for your research opportunities. So if you do the thesis option, that indicates that you have already done some research work. So this will definitely be a plus. And for some industry jobs, they also look into students whether they have any research opportunities. So in that sense, thesis option takes more effort than non-thesis option, but it could be useful in your future. From part-time student to full-time student, do you need any paperwork to do to transfer? I think that depends on whether you are an international student or not. If you're not an international student, you do not need the paperwork. If you're an international student, I think you do need the paperwork. Okay. Okay. So, yeah, some elective and the prerequisite requirement non-used. How can we? Okay. Yeah. If you if you want to register a course but it's being blocked by a prerequisite, you can ask your course instructor. If you grant you to take the course, you can then talk to Christy, and Christy can provide you the special permission number. And also, I like to say that there's a course 546 that is being offered by Professor Dario Pompili. It is about wireless communications. It is a very interesting course that if you want to look into networking and wireless areas. And we recently just removed the prerequisite on this course. So if you're interested in wireless networking, millimeter wave communications, definitely this is a good course for you to take in the fall semester. Okay, for the master's program, usually the regular is 2 years to complete, but if you need more time, it is fine. Yeah, you can register for online courses to maintain your full-time F1 status. And I think one student wanted me to go over the PhD computer engineering concentration course requirement. Okay, let me take a look at that. Computer engineering. Okay, so for the computer engineering, okay, for the PhD courses, okay, so you can see that, okay, we like you to choose 3 core courses, okay. Out of 5 core courses, we like you to choose 3 of them, okay. And then what you like to do is that you can choose 1, okay, from the list here. And especially for the 579 advanced topics in computer engineering, actually, there are many courses that you can choose from. And if we said, if you have already got any core courses that are mentioned here already, but you cannot transfer, okay, you have to take other core courses from the ECE department, either from this list, or you cannot find any other courses from this list. I can recommend you the core courses from other areas that to fulfill the need here. Yeah, for the SPN, I think I've already talked about that, right? You can talk to your course instructor once you get approved, or talk to me once you get approved. Christy can provide you the SPN. Yes, for the master non-thesis student, if the core courses or recommended elective courses are not listed on this semester, you're flexible to choose course from the other area. Yeah, thanks for the clarification. Christy said that for the courses outside of the ECE department, we cannot provide SPNs. You need to contact the course coordinator, yeah, from the other department. Yeah, if you're in the 5th year of your, if you're the 5th year student for the BSMS program, yeah, you can go ahead and start contact advisor if you would like to do a master thesis. Yeah, and if you want 1 more semester to finish your degree, definitely that is fine. Okay, for the master's non-thesis option, what you're going to do is that you need to write a technical paper, and usually that technical paper is from your course project. So in order to find advisor for a technical paper, if you'd like to choose, you took a course before and you did a course project, and you want to convert to do something more on that course project and convert it to write a technical paper. So you can choose, you can talk to your course instructor and choose him or her as your advisor. And then, okay, your course instructor will guide you through, okay, how to convert your course project into a technical paper. Okay, so this is how you find an advisor for that. Or for the non-thesis option student, you can also do some research work. You can find a professor, you do some research work in that lab. Okay, instead of writing a master thesis, you can just do 1 semester's research work and then write your research work into a technical paper. So you talk to a faculty about that. If you're interested in his or her research work, you can do that. And then that faculty will become your advisor. And when you're doing the research in their lab, you can communicate with them how to write a technical paper. And this will also be a 1 semester of work, and you need to register for the special problems course with that professor. Okay, I hope that helps.
Dr. Chen.
Yes.
So for the competency concentration, the course requirements, how many courses I can take from the next list? I mean, you mentioned take all courses from the list. So how many courses I can take? If I have, I already taken all courses or 2 courses from the first list.
Which concentration?
Computer engineering.
Computer engineering. So you're a master student?
No, PhD student.
You're a PhD student. Okay. So you said you have already taken 2 courses from that list.
Yeah, I already taken 1 courses mainly from the first list. I think you are in the same page. Yeah, this page. So how many courses I can take from the next list?
Oh, so for the core course, okay, core course, you have already taken 1, right? So we usually would like you to take 2 more courses, okay, in the core course. And then you can take 1 more, okay, from the next, from this list. Of course, okay, this is just to fulfill the 4 core courses qualified exam requirement. After that, you can take as many courses as you want in the list.
And can I take the core courses from other concentration upon advisor approval?
Yes, upon your advisor's approval, yes, you can take core courses from other concentration.
And I can sit for qualifying exam for those courses, right?
Yes, yeah. Yeah, when you do the qualified exam application, you need to ask your advisor to write a paragraph, okay? To either send me an email or write a paragraph, append to application to do the justification that he or she agreed that you take a core course from other area and what is the need for your research.
Okay, thank you.
Okay, you're welcome. Yeah, I see another Gregory is asking for software engineering of web applications 568, 567. But not on the online schedule of courses. Yeah, 567 should not be it's not on the online schedule of courses. That means that we're not going to offer it in the coming semester. 567, I don't think it's a definite prerequisite for 568. For this one, we'll be able to grant you the permission to take 568. Yeah, that is fine. If the student want to take both the prerequisite and the core course in the same semester, since you're familiar with the prerequisite in your bachelor's, that is fine.
Hi, I have a quick question.
Yes, go ahead.
I'm not sure if I don't think you went over this already, but for control systems, a concentration and control, not control systems. I'm sorry, communications. It doesn't have like computer engineering and software engineering. Like you can for required courses, you can pick 3 required courses from there, and then you can do the rest elective option. It just has like 9 required courses. Are those 9 or 8 required courses? Are those just, you know, anybody that's taking a concentration and that has to take those 9 courses?
Well, okay, for the communications, you're talking about the master's courses, right? Okay, let me bring that up quickly. Okay, for that, okay, usually it's not a hard requirement as I talk about, okay? If the core courses are not being offered, okay, for 2 semesters, you're flexible to take the core courses from other concentrations.
Okay, so under this core course requirement, you have a sample 4 core courses. So the core courses are here, which are the required courses from the above, right?
Yeah, I would like to say that, okay, for the PhD students, the core courses are strict. Okay, the core courses are strict. area. For master students, for master students, okay, the core courses and electives, those are guidance. Okay, it is not a strict requirement. Okay,
Oh,
so
I
this
see.
for the communications area. And you can see that we are offering 3 core courses for the fall semester and another core course in the spring semester.
Understood. So as long as if I'm a non-thesis option, I'm doing a technical paper, as long as I'm taking 30 credits from mostly the core courses and then I guess the recommended courses, I'll be okay.
Yes, right.
Understood. Thank you so much.
You're welcome. Okay, students are asking that whether if you're international students, you choose 2 core courses of 3 credits and the full GA of 6 credits. Okay, I like to actually touch base about the TA and the GA issue. I don't think I talked about that. For a PhD student, many of you once you got admitted into the program, you either have a GA-ship or you have already found advisors. So you have a TA teaching assistantship, or you have already found an advisor. You have the GA assistantship, which is a research assistantship. And I know that many professors, they have the students, okay, 1 semester as TA and 1 semester as GA. So as a TA or as a GA, you're going to register for 6 credits each semester. But this is just for your working purpose. Those are not credits that you can count it into your coursework or into a degree work. Okay. And for the teaching assistant and the research assistantship, for the master students, if you're interested in doing research work and if you find an advisor, you may first volunteer to work in his or her lab. But if you want to do some serious research, okay, the advisor may also fund you as a research assistantship. And for master students, if you're in a very good GPA standing, okay, we also consider you, okay, as a teaching assistantship. So you can also apply for teaching assistantship, okay, through a letter on our department secretary. Okay, you can also apply for master students. You can also apply for grader positions. In each semester, we also have grader positions. Grader positions are hourly paid positions that you can apply for through a letter, and we can also consider you to assign you grader positions. And for teaching assistant and research assistantship, your tuition, okay, for the teaching assistantships, your tuition will be paid by the department, and for research assistant, your tuition will be paid by the grant of your advisor. And you also get stipend as a teaching assistant to help to teach labs, to grade homeworks, and help to grade quizzes for the course instructors. You get stipend, and for the research assistant students that you're doing research, you also get stipend. Okay, so this is the part for the teaching assistant and also for the GA-ship, for the research assistantship. Yeah, for the master student, yes, yeah, for the electives, you can choose for definitely from other concentration. For the master students, the core courses and electives are just a guideline. It is not enforcement. For the 573, for the 573, I need to check whether it's being offered, will be offered in the spring 2022. So please send me email to follow up and I will check for you. Yeah, Christy is helping answering questions for the international students to maintain their degree. Yeah, so once you arrive here, okay, okay, for the international students, okay, you should enroll for at least one hybrid or in-person course to maintain your visa status in the US in 2021. And what we do in our department is that if you can find an advisor, okay, if you can find an advisor, you do this special problems course. That would be great. If you cannot find an advisor, you can always register a special problems course of 3 credits with me, and we're going to read some research papers to guide you through some basic research concept. That can also count it towards your 21 credits in our department.
Professor Chen, can I ask a question?
Yes.
So I'm looking at electives under software engineering, and there's a machine learning course from the CS department. And I looked up that course. Apparently that course also has a prerequisite. That's also in the CS department. So in order to take machine learning, I have to basically free 2 slots. Well, from my understanding, you can only take up to 9 credits, which is 3 courses that are outside of the ECE department. So what should I do about it? Because we only have 3 slots, and in order to take 1 course, I already have to, free up 2 slots. And I'm just kind of curious.
I'm a little confused. What do you mean here? When you take up to 3 courses from outside of the department, it does not have to be in 1 semester. I'm not sure what is your question.
Yeah. So okay, let me rephrase it. So for machine learning, for CS machine learning, it has a prerequisite that is also from the CS department. And that already took up 2 courses. Right. And I also want to take another CS course, which is called NLP. And that course itself also has another CS prerequisite. So that's like 4 CS courses. But I only want to take 2 courses, which are machine learning and NLP.
Yeah, so in that case, as we talked about, right, you can talk to the CS course instructor and asking them whether it's possible to waive your prerequisite requirements.
Okay, I see.
Yeah, or another possibility is that you can also, sit in for the courses that you like to take. I know that, when I was doing my PhD study, I sit in many courses from other departments, not really counting for my degree requirements.
Okay, got it. Thank you.
You're welcome. Yeah, the question about whether the F2 dependent have to maintain a health insurance mandatorily. Actually, I'm not sure about that policy. I think you need to still check with the Rutgers Global about that part. Yeah, and also as we said at the beginning of the orientation and during the semester, and if you have any questions, you can always email me and email Christy about your questions. And you can find my email address as the graduate director, and also Christy's email address as the graduate admin. So we'll be here to help you. And we welcome you to join our department, and we hope you have a successful study in the ECE department at Rutgers University. And there are also, in addition, to the course study you have, there are many activities usually on campus, and I hope it will gradually go back to normal, like the gym activities and the club activities. There are many opportunities for you to make friends here, and on top of what you're going to learn on the campus here. So I hope you have enjoyable learning experiences and also living experiences here in the ECE department and also on campus. And hopefully everything will go back to normal as things become better and better. Okay, thank you so much for attending the orientation today, and we look forward to the starting of the new semester. Okay, thank you very much. So we're going to end the recording and also end the orientation. Okay, we'll see you in the new semester. And I think in the new semester, I'm going to post my office hours. And most likely I will be in the office on Tuesday, graduate director's office, and Christy will be in the office on Thursday. So if you have questions, you can drop by. And also if you have forms that need our signature, you can send us emails about that. And Christy and I will help you to take care of those. Okay, thank you, and looking forward to the new semester. Okay, bye-bye.